Hello, welcome to the Wednesday, September 6th, 2017 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. It was sort of a year ago that we really saw Mirai take off, so I put together a little summary of where we are today with Mirai. Last week, of course, I set up that DVR torture chamber, so I want to see how many infected hosts are still out there. Well, it looks like we're talking about 100,000 hosts that are infected with some form of Mirai or similar malware. We do actually see less scanning on port 2323, which was one of the hallmarks of the original Mirai variant that we observed, but these days that has actually died down quite a bit. Overall, we do see a half-life of infected Mirai hosts of about 150 days now, so Mirai is certainly going to stick around with us for quite a while, in particular since there are still new systems being discovered with new default passwords, so they're going to be just added to the list. And if you're using Apache Struts for your web applications or web services, it's time to update. A new critical vulnerability was identified in Struts that has been patched in 2.5.13. The vulnerability does affect the REST plugin, so if you're not using REST, you should be able to turn that off and secure your site that way. I would still recommend that you update just in case that it gets enabled by mistake. Now, the problem here, as before, was with the deserialization of untrusted data. There is no exploit available at this point, but an exploit shouldn't really be all that difficult to come by. So definitely update this week if you can at all, or at least check if there's any kind of web application firewall ruler so that you may be able to use to protect yourself. If you don't see an exploit by the time you're listening to this podcast, you should definitely expect an exploit by the end of the week. And sticking with web services here for one more story, and in this case a very specific one, the Mastercard Internet Gateway Service. This is a payment service that's being offered by Mastercard in order to essentially charge and validate credit card transactions. And it is one of the options that you have when you're accepting credit cards on websites. The reason I'm discussing this flaw is less because of the specific implementation. You're probably not going to write your own payment service like this, but it does show some of the difficulties in actually authenticating and hashing data correctly. There are actually two flaws that are being discussed here at tinyhack.com. The first flaw has already been fixed. It's related to the MD5 hashing of data. Now, in this particular case, actually, the fact that an MD5 hash was used wasn't the weakness. It wasn't that the hash was too weak. It was just the way the data was actually encoded before it was hashed that was the problem. There was no delimiter between the data, and that as a result could be used to essentially make one piece of data overwrite another piece of data. The newer flaw is somewhat similar in the sense that they did now introduce a delimiter, but if the delimiter itself does show up in data being sent to the gateway, that delimiter is not encoded. So I can inject delimiters. And this is a very classic vulnerability. Whenever you're encoding data, you have to encode it correctly for the particular output mode that you're using, the output context. And in this particular case, well, they sort of used a URL format with ampersands. So yes, you should have to encode the ampersand, but the specification specifically said not to do so, which then led to the vulnerability. So pretty interesting vulnerability, in particular if you're dealing with web services with data encoding. You always have to make sure that if your delimiter shows up as part of your data, you have to encode it somehow, or at least not allow the delimiter to show up as part of the data. And one of the security improvements that Apple announced for the next version of Mac OS, High Sierra, which will probably be released within the next couple of months, was more secure kernel extension loading. Now, kernel extensions for a while now had to be signed with specific certificates. Apple was very restrictive in handing out these certificates, so these are not normal developer certificates. But in addition to this, with High Sierra, if you are loading a new kernel extension, it will actually require the user to specifically approve that kernel extension. That has caused some headaches, given that enterprises or so don't really have a good way to centrally approve these kernel extensions. But the reasoning behind it was somewhat to prevent vulnerable kernel extensions that are validly signed from being loaded. Now, at issue here is how valid of a threat is this, and how valid is the defense against actual malicious attempts to load kernel extensions. Turns out that if a user has root on a Mac OS system which is required to load kernel extensions, then they also have access to the database that tracks the legitimate and approved kernel extensions, so they essentially can just overwrite that database. More details about this can be found at the Objective-C blog, and maybe there's a way here somehow to actually get a tool working that will enterprise-wide approve kernel extensions. Well, that's it for today, so thanks for listening and talk to you again tomorrow. Bye.